Today we are going to start a new topic. The name of the topic is circles, and let us first discuss some of the important points which we should know in a circle. So let us start with the introduction part. Now, the first point which I should know in a circle is center. It is said the midpoint of the circle which is equidistant from all points on the boundary of the circle is called center of the circle. It is denoted by O. So now let us draw one figure having a circle. So the point which is equidistant will be O and A. So here O is called center of the circle. Then second point which is there, that is radius. Now the definition of radius, or the point I should say, from the center O, if we draw a line segment to boundary of a circle, then it is called a radius. It is denoted by R. Now here in the figure I can say OA is my radius R. Now then the third thing which we should know is circumference. The boundary of the circle, in other words, perimeter of a circle, is called circumference. It is denoted by capital C. Now moving forward, the fourth definition says diameter. If 2 points on circumference are joined, with a straight line, passing through center, then it is called diameter. It is denoted by D. Also D equal to 2 times radius. Now if I make a line like this, then this is my center O and this is a point A and B touching the circles. So then AB is called diameter. So this distance is my diameter. Then coming to the fifth point, that is chord. If any 2 points on the circle are joined, then it is called a chord. Diameter is the longest chord of the circle. Now here if I want to show the chord, I can say if I join this point and this point, that is C and D, if I join together, so it is chord. Then moving ahead, sixth point says arc. Any 2 points on circumference taken on circle is called an arc. Now let us understand this by an example. So suppose if I am drawing a circle and I am taking any 2 points A and B. So this is my B point. So this is my A point, this is my B point. Now if I draw or if I take this part AB, the colored part, then it is called an arc of the circle. Now moving ahead, the seventh point says sector. If any 2 points on the circumference are taken on the circle and joined with center O, then they form a sector. Now Here if I want to show the sector, I can say if this is my center O and I join OB and OA. So OB and OA are the radius of the circle. So the shaded part is nothing but my sector. Then eighth point says segment. Two points on circle are joined with chord then the whole part will be segment. Now here if I want to show a segment, I can say if this is C point and this is D point, and if I join this with a chord, that is straight line, and this whole part will be my segment. Now next point says lines and circle. So if we see the first figure carefully, so a circle and line are not touching each other, but in the second figure a circle and a line are touching at one point. So such line is called a tangent. So I can say a line which touches a circle in one point is called a tangent to the circle. Here figure 2, A point is the point where the tangent is meeting the circle. So A point is called point of contact. Or the contact point. Now in the third figure, if you see carefully, the circle is touching to 2 points on the line. So such a line which touches the circle in 2 points is called a secant. So I can say a line which touches a circle in 2 points is called a secant. Figure 3. Now if I talk about tangents, I can have infinite tangents to a circle at different points, but at one point I can have only one tangent. Now coming to the next point, that is theorem 10.1, it says the tangent at any point of a circle is perpendicular to the radius through the point of contact. So if I draw the figure, here suppose this is the circle with center O and I am drawing a line which touches the circle exactly at one point A, and now I am drawing this point A. So I can say the line segment, or if I draw the radius from the center O, so then it will be exactly perpendicular to this line. So this the theorem says. Now this theorem proof is not generally asked, as it is a theoretical proof, but let us understand that also. Proof: take a point Q on this side, let me call as xy, on xy line other than A, and join OQ. Now let me take one point OQ. Let me say this is my point Q, and I have joined it with a dotted line. The point Q must be outside the circle. Here to note that if Q lies inside the circle xy becomes secant to the circle, because then it will touch the circle at 2 points, so it will be a secant to the circle, not a tangent to the circle. So therefore I can say that OQ will be greater than OA, as this happens for every point on the line xy other than point A. Thus OA is the shortest distance between O and A. Therefore, OA is perpendicular to xy. Now next is exercise 10.1. Question 1 says, how many tangents can a circle have? So the answer is, there can be infinite tangents to a circle, as a circle is made up of infinite points which are equidistant from a point O, which is center. Since there are infinite points on the circumference of the circle infinite tangents can be drawn to the circle. Now question 2 says filling the blanks. A tangent to the circle intersect it in dash point or points. So it will be answer will be 1 point. Then second one says a line intersecting a circle in 2 points is called. So this is definition of secant. So the answer will be secant. Then third, a circle can have dash parallel tangents at most. So here the answer will be 2. Then the fourth one says the common point of a tangent to a circle and the circle is called point of contact. So point of contact. Now third question says the tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q so that OQ equal to 12. Length PQ is, so see here I have drawn the diagram and shown the whole situation. Now I can say in the figure the line that is drawn from the center of a circle to the tangent PQ is perpendicular to PQ. So therefore I can say OP is perpendicular to PQ. Now using Pythagoras theorem, in triangle OPQ I can say OQ square equal to OP square plus PQ square. So OQ is 12, so 12 square equal to OP is 5, so 5 square plus PQ square. So therefore PQ square will be equal to 12 square minus 5 square. So which will be equal to 144 minus 25. So therefore PQ equal to root of 119 centimeter. Now next question says draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant to the circle. So here first I am drawing a circle. Now to this circle I am drawing two lines. One should touch the circle in 2 points. So this is a line which is touching the circle in 2 points and one line should be such which touches the circle in 1 point. So that is this line. Now I am giving them the name. So here it is touching at A and B point and I am showing it with an arrow so that it is a line, and this line is touching the circle at C point. So I can say, let me give the name X and Y to this. So I can say AB line is a secant to the circle and XY line will be a tangent to the circle.